Hi and good morning to Mr. Azim bin Muhammad Arshad. So this is a presentation for Lab 2 Radiation for BMM 3531 Engineering Thermodynamics Lab. So my name is David Fritson Anakiat, MA 19154, and also my friend Muhammad Izuddin bin Jamal Abdul Nasir, MA 19209, and also Krishna Analaki Munyandi, MA 18219. For introduction, there are three modes of heat transfer, which are conduction, convection, and also radiation. Radiation is different from convection and conduction as it does not require a physical medium to take place, and it can radiate in vacuum also. Radiation is known to be the quickest heat transfer mode since it happens at the speed of light. Thermal radiation has a range of wavelength ranging from the longest infrared rays to the shortest UV rays. So if conduction, it happens between two physical contact of any object, and for convection it is between the air and also the surface of the object, whereas the radiation is not require any physical contact between the object. So objective of this experiment is to investigate the effects of distance on radiation heat transfer characteristics. And the next objective is to investigate the effects of aperture opening on radiation heat transfer characteristics. And Stefan Boltzmann law states that the total energy radiated per unit surface area of a black body in unit time is directly proportional to the power of the black body's thermodynamic temperature. Stefan Boltzmann law, also known as Stefan law. Stefan Boltzmann law can be written as, you can see there, the QP equal to sigma Ts power of 4 minus Ta power of 4. Area factors. Heat transfer rate from one radiating black surface to another is depending on the amount that each surface can see from other surface. In order to solve radiant heat transfer problem, an area factor F is introduced, where F is defined by the fraction of energy emitted per unit time by one surface that is intercepted by other surface. Area factors are found by analysis, numerical approximation, and analogy, and results for common configurations have been published in graphical form. So that's all from me. I will pass to my friend. Thank you.
Assalamualaikum and good day. My name is Muhammad Izuddin bin Jamal Abdul Nasir. My metric number is MA 19209. And for my part is methodology, and for the radiation lab, we have to make two experiments. Firstly, the effect of distance of radiation, and secondly, effect of aperture opening of radiation. So this is the laboratory setup for the first experiment, and this is for the second experiment. For the first experiment, it consists of heater surface, radiometer, and also a distance marker to set up the distance. For the second experiment, we have heater surface for radiation sources, aperture for the opening and the size of the radiation, and also for the radiometer. before we start our experiment, we have to activate the machine. Firstly, we have to turn on the main switch and the heater, and then we have to set the temperature for this experiment, which is 400 Celsius. How to set the temperatures? By press once the oval shape button, and then we choose up or down arrow and set the temperature that we desire, and then press the oval button to lock the desired temperature, and we have to wait for the temperature to achieve a stable condition. For the first experiment, effect of distance, we have to firstly set up the temperature at 400, and then we have to move the radiometer away from the heater at 200 millimeter, and then we took the reading of the radiometer when it arrived the steady state, and we have to repeat this experiment by adding 100 millimeter until reach the distance of 900 meter. And for the second experiment, effect of aperture opening, the temperature is the same, but we have to distance the aperture from the heat resources at 200 mm and the radiometer at 400 mm. For this experiment, the change only at the aperture opening, and then firstly we have to, the distance of the aperture opening is 5 millimeter, and take the reading of the radiometer when it reaches the steady state. And then we have to repeat the experiment, added 5 millimeter, and until it reaches 400 meter to get the data.
This is the result explanation for experiment lab 2 thermodynamics lab. The result obtained from the radiometer readings needs to be corrected, as the radiometer measurement includes the infrared radiation from the surrounding. The reading obtained is multiplied by the correction factor given by the manufacturer of the radiometer. For this experiment, the correction factor is CF equals to 0.724. The data is tabulated and the data is analyzed by using a graph. Two experiments were carried out for this experiment. Test 1, effects of distance, and test 2, effects of aperture opening. For test 1, effect of distance. For this, the distance was started from 200 mm. The distance was from 200 mm, moving with an increment of 100 mm until 900 mm. The radiometer reading was observed, and was multiplied with the correction factor. The graph of the actual, this is the graph of the actual reading against distance. The graph shows the inversely proportional relationship graph. This shows that as the distance increases, the actual reading decreases proportionally. The decrease in the actual reading means that less radiation exposure is expected, as the radiation might scatter over the distance. Next, the effects of aperture opening. For this test, the distance was fixed at 400 millimeter. The aperture opening starts from 5 mm and increases by 5 mm each time. The radiometer reading is again taken and multiplied with the correction factor to get the actual reading. This is the graph which was obtained from the experiment data. The graph shows the actual reading against aperture opening. The graph shows a positive linear graph relationship. This shows that as the aperture opening increases, the actual reading increases as well. The increase in the actual reading means that an increase in the aperture opening means more radiation exposure.
The next part is about the discussion in this experiment. Firstly, about the mechanism of radiation heat transfer. So radiation heat is transferred via electromagnetic waves with photons. There are no particles involved. Radiation can even work through the vacuum of space. As example, the sun. The heat from the sun can even reach the earth with that 150 million kilometer waves. But the space uh, there are no air, or it is vacuum. The second is relationship between distance and radiation heat transfer characteristic. From the experiment, we can see that the closer the distance to the object to the radiation source, the intensity of radiation will increase. And secondly, for the second experiment, the relationship between the aperture opening and radiation heat transfer characteristic, we can see that the bigger the aperture opening, the higher the intensity of radiation heat transfer. And lastly, the factor that affect radiation heat transfer. Firstly, the distance of object near to the source of heat of radiation, it will increase the temperature. And also, if the area of material, which means the bigger area exposed to the source of radiation, heat transfer give a better radiation rate. And lastly, for the darker color and rough texture material surface, it have higher radiation rate because it good heat absorber and heat emitter.
For the conclusion of this experiment, we can see that we set out to investigate the link between the distance and radiation heat transfer characteristics, as well as the relationship between aperture opening and radiation of heat transfer characteristics when we began this experiment. After finishing the experiment, we may make two conclusions. The properties of radiation heat transmissions are inversely proportional to distance and positively linear to aperture opening. Due to the divergence of radiation from the source, the radiation decreases with distance. Aside from that, because of a bigger aperture intercepts more radiation, the rate of radiation increases as the aperture size grows. Finally, a few additional factors influence radiation as well, such as an item's surface quality and the temperature differential between an object and its surrounding. Thank you very much for listening to our presentation. Thank you.